Hi guys, today we're going to be doing part 4 in the video series that I've been doing on how to build DIY security cameras. Now, the last few that we've looked at have been related to how to use a camera with a Raspberry Pi or a similar board like that and connect it to a DVR. We looked at how to do that with a Raspberry Pi camera and a USB camera. Now, today I'm going to be looking at this from a different angle, and that's how you can use just a standalone application or a standalone board without the need for a DVR. So basically, you're going to get a lot of the same kind of things that you would get from a DVR, except everything's going to be done on board. So the camera is going to be connected to the Raspberry Pi, and the Raspberry Pi itself is going to be able to do the motion detection, and it's also going to be able to apply AI to do object detection against the video stream as well. So I'm going to show you all the pieces of software that go into making this a reality, and then I'll show you how to set it all up, and then we'll show you a demo of it working. So let's do an overview of the solution before we get into the technical details. This is pretty straightforward. The first thing you'll need is a camera. You can use a USB camera or Pi camera. You configure them the same way within the software. Now, the main software that we're going to be using is on a Raspberry Pi or a similar dev board is an app called Motion. Now, Motion is basically there to receive a stream of data from a camera and analyze the frames. If it detects differences between a series of frames, it knows that something is moving in the frame, and that's how it knows that there is motion. Now, once it detects motion, there's a number of different things that Motion can do. It can record video, it can record still images, and it can trigger downstream applications to run. I'm mostly interested in the application recording data to the disk as images. So once a camera sends data from the camera over to Motion, and Motion detects that something has moved within the frames, it's going to write those images to the disk as JPEG images. Now, I could hook into the hooks for Motion that trigger downstream scripts, but Motion just generates a lot of data, and there's just no way that I could process all of that data on a Raspberry Pi. It just doesn't have the compute capacity, especially if I'm going to be using AI. So I'm basically just going to take a sampling of that data, and that's probably going to be good enough for my application anyway. So once Motion detects something and it's written to the disk, there's a script that I wrote that's basically just monitoring the output from that. And so when a file gets written to the disk, the detect script then picks up an image. Now, if nothing is happening, then the detect script is idle and it's not doing anything. But if something is written to the disk, it's going to pick up one of those images and it's going to start processing it using another piece of software that's running in a Docker container called CodeProject.AI server. Now, what CodeProject.AI server is a piece of software that basically does object detection within an image. So it's got an AI model that looks at the image and tries to figure out if it can find things like people or dogs or cats or vehicles of any kind. And if it does, then it will give data back to whatever's calling the CodeProject.AI server with the bounds of where that object might be in the image. So if it detects a person, you can draw a box around the person and it gives a confidence score, basically 90% confident this is a person or 30% confident this is a person or something like that. So my detect script takes the image that Motion wrote to the disk and sends it up to the CodeProject.AI server. And then if it finds anything, then CodeProject.AI server is then going to return the results of that back to the detect script. And then the detect script then will then put that onto a queue. Now, after it puts that onto a queue, after about a minute interval, the script is also going to be looking for things in that queue. If it finds something, then it's basically just going to kick out an email with those embedded images with the boxes are drawn around the objects with the object detected as well as the confidence score. And then that will show up in my inbox with the images embedded in the email. And that way I can see what's going on with whatever this is detecting. And it's more or less a notification that something has been detected by my camera. And so you can configure email to be your notification method for this particular solution. So I'm assuming that you're going to be connected into your Raspberry Pi via SSH for this to work. So you'll have to install the SD card and make sure that your camera's plugged in and make sure everything's up and running and you're in the command prompt for your Raspberry Pi. Now, once you have that up and running, we're going to run a series of commands into this to install the software that we just mentioned. So we're going to be installing Docker, we're going to be installing Project.AI server, Motion, and then we're going to install the little script that I wrote, and then we're going to configure all that. Most of this is pretty straightforward. So the first thing I want to do is get Docker installed. Docker is actually really easy to install because Docker provides a script for that. So if you want to run this command, and I'll make all these commands available in the video description down below, so you can just copy and paste them. But this right here will install will actually download a script to install Docker, and then you can run that just using shell. So this one will just install Docker. I've already installed it right here. And because I have this already installed on my machine, I don't need to reinstall it, but that basically will install Docker on your machine. Now you'll want to be root to install all this stuff, but if you do docker-v, you should get a version of whatever version of Docker is currently available. And as of the recording of this video, 24.0.2 is the current build that's available on Raspberry Pi. And you don't have to figure out any of the dependencies. It'll just figure out all that for you, and you don't have to figure out which version to use or any of that. It's going to be able to detect that you're running this on a Raspberry Pi. It'll download all the binaries you need to install those correctly. So once that's done, the next thing we'll want to do is install the CodeProject.AI server, which is a container. And the container image is pretty heavy, so it takes a while for this to complete. I've already downloaded it, so the first time you download it, it takes a couple minutes to download and extract everything and get everything in place. But the command for that is just basically a Docker run command. You can do a Docker run command as well as download it all in one fell swoop. So I'm just going to run Docker run, and this is basically just telling it what I'm going to call this particular server, and -D puts it into the background, and this is the port that it's going to be forwarding to the CodeProject.AI server. So it's going to be exposing port 32.168 to the backend port on the container 32.168. And then this is the image from Docker Hub. And so this will download and start the image. I've already got this running, and so I don't need to start it. That's why I'm getting an error that says containers are running. So if I do a Docker ps-a, you can see that I currently have the image running, and it's the same version of what this particular one is using right here. So this one is currently running, and I don't need to reinstall it once it's up and running. So once that's configured, the next thing that we'll need to do is actually configure the CodeProject.AI server. So I'll show you how to do that now. So to configure the CodeProject.AI server, you'll need to connect to it in a browser. So this is a UI-based configuration. So to do that, you basically just point it to the IP address of your Raspberry Pi and then the port that you exposed in Docker. So 32.168 is the port that is exposed on. And that'll bring up this page right here, and it gives you some statuses right here on the status page, some server logs, system info, and then modules. Now we want to install modules on the install modules page right here. Now the main one that we want to use for this application is object detection. So there's 3 object detection models that this supports out of the box. Some of them come pre-installed, and then some of them come installed when you click the install button. So if you want to install one of these, you can click install right here, and that will install the module for you. And so this will download all the dependencies and do all the magic for you so that you don't have to figure out how to make all that work. And if you've ever tried, it's not trivial to do. If you've ever tried to set up all of the dependencies to run an AI model for object detection using things like pandas and Python and all of these other things that are based on TensorFlow and all these other various binaries that you have to install with the right versions and all that, it can get really, really frustrating when something doesn't work and you have to figure out what version of whatever thing you need is off. And so this just kind of takes the edge off of that for you so that you don't have to sit there and wrestle with all that. So once it's installed, you will have a status page right here that'll tell you everything that is currently installed on the particular server, and it's currently installing mine. So we'll come back when this is done. So once you've installed a model, it's pretty easy to stop and start it. So I've got object detection YOLO 5 3.1 and YOLO 5 6.2 installed. So I'm going to stop 3.1. That's the one that you can install after the fact, and then you can start this YOLO 5 6.2, which is one of the more later versions of it. You can start and stop it right here as well. So it's pretty easy to do for this. You can also configure this based on the model size, and that basically is going to determine the amount of CPU that it's going to need for the computation on this. So if you want to do tiny, that's less CPU intense. Large is going to be more CPU intense. The more CPU intense it is, the longer it's going to take. So the results won't be as good if it's a smaller model. But for this application, probably small is the one I would go with. And that's the one I've been using because it seems to work fine for all the tests I've run on this. So it seems to work really well. So you can use all of these for whatever you're doing. But once it's stopped, you can start it back up and everything is up and running and your CodeProject.AI server is ready to go. So the next thing we want to do is set up Motion. Now Motion is actually really easy to install because it's just an apt package. So to install this, just run apt get install as root, and then, of course, install Motion. Now, I've already got the latest version on mine, so it's not going to install anything. But to configure this, next we're just going to run nano /etc/motion and then do motion config. Now, there's a couple of things in this that we'll have to set. So there's some parameters that we have to turn on and tweak in this config file to make sure everything's up and running. So the first thing that we'll need to set up is the target directory. Now, this is the output for pictures, snapshots, and movies. The pictures are what we're mostly interested in. So I'm going to put this in images/in. And now that's that's going to be the input folder for the detect script. So that's where it's going to write those images to. So once you have that set, the next thing to set is the video device. Now this is the source for the camera. So to find that, you can either know it or you can run a little utility to list your USB cameras and your other cameras that you have available. So you can use a video for Linux or v4l2-ctl and then do --list devices, and that will show you a list of all your devices. I'm going to be using this Logitech webcam, and it's on video 1. So I'm going to do /dev/video1. So let's go back into my file, and that is going to be what I put in right here. So I've set my target directory. I've set my video source. Now there's some other things that we need to tweak for the resolution and the sensitivity. So the resolution is the width and the height. So we want to use the width and height that's going to work with your camera. So I'm using 1080p on this particular USB webcam. So width is going to be 1920 and the height is going to be 1080. Now the frame rate, of course, is how many frames per second you want to capture. 30 is the default. You can change it to 10, which is probably useful, good enough for video detection on a video camera for something like a security device. If you want to do higher frame rates, of course, if your device supports that, then that works fine too. But 30 is fine for this. And the other thing that we need to tweak is threshold. Now, threshold controls the sensitivity to motion. So the higher the number, the less sensitive it is. So if you want to make it very sensitive, you lower the threshold. If you make it more or less not very sensitive, you can increase the threshold to more than 1500. 1500 is default, and that seems to be a good number for most use cases. So I'm going to stick with that. And once you have all of those defined, you can hit Control-O, save your file, and hit Control-X. And now Motion is ready to start doing its thing. Now we want to make sure that directory is where we need it to be for the output. So you'll do make dir /images, which I already have. And then you can do make dir /images/in to ensure that it's already there. And I'm going to need one other folder as well. I'm going to call it out, which is already there as well. But in any case, once you have these images folders created, now Motion's configured and CodeProject.AI is configured. The next thing that we'll need to do is get the Glueware, that is that script that kind of connects these two together, and we'll need to download and configure that. We have CodeProject.AI installed and set up now. We have Motion installed and set up now. Let's get the Glueware, that is that little script that I wrote to bring the two together. So we're going to clone the repository for that. So let's do a git command here to clone that repository. Git clone and paste in that URL. And that's going to clone get into a folder called detect. So I'm going to go cd detect, and we should have a couple of files here. And we have basically the script file, which is detect.js. There's this settings file, right here. And then there's this package.json file, which contains all this. So I'm basically going to move all this into the images root where we created that, the images folder where we have the in and out. So let's go to that folder now and work in that folder. And now we should have in and out, and then the tech.js, and then there's package.json, settings.json, and then this package.lock.json file right here. So once we're in here, we need to install Node.js. So we're going to use something called NVM, which is a Node version manager, to install Node on this particular box. So now we're going to install NVM. It's pretty easy to install. So we're basically just going to run a command that's going to download a script and pass it into Bash. So this is going to get it from the repository from GitHub and then pass that into Bash right here. So let's go ahead and run this. And it's already installed on my box here. And so I don't really need to install it. But once you have NVM installed, you can do -v, and it should give you the version that you've installed, which I've got 39.01 or 0.39.1. And then if you want to get a list of versions of Node.js that are available, you can do NVM ls. And this is going to list lots of different versions of what is available for Node.js. So now we want to install one that is more current. So 18.16.0 is probably good for what we're going to install. So if we want to install something that is current but not bleeding edge, you can do this. That's an LTS version, and then this is the latest stable version. So LTS means that it's a long-term support, and this is the latest stable version with the newest features. But of course, there's old versions if you require that. So you can go NVM install, and then you do v, and then you just basically put in the whole string right here, and that will install that particular version of Node.js on your machine. So that will install Node.js and NPM, which is the Node package manager, which you'll need for this to run. So you can use NVM to switch between versions of Node.js, which is really a nice feature of it, but it's probably the easiest way to install Node on any platform, including the Raspberry Pi or other dev boards like it. So once you've installed Node that way, the next thing to do is to install the packages that this will need to run. So let's go ahead and run that command. So to get the packages installed, just run npm install in this folder, this images folder that we have, and that's going to download all the dependencies that this script uses. It's just using a lot of Node.js packages for it, and this might take a few minutes, so we'll come back when it's done. So let's go through the configuration for this particular script. Now, it's all in one file. I decided to put it into a file rather than on the command line because it just made more sense, because there is so many parameters that this thing needed. So it's pretty straightforward. Now, a lot of this stuff you might not need to touch, but you definitely want to go through it. There basically are a couple of folder paths that we need to figure out. The one is the path to watch. That is, where is the output for motion, which should match what you put into the motion.config file, which is images/n. This is the output path. And this is where the output images that are going to have the boxes on them are going to be written to. And it's where the email daemon is going to read these files from, and then it's going to embed those in an email. So you'll need that as part of the configuration here. The height and width right here should match what we put into the motion config as well. So this should match the width and height of the camera. And so that way we are able to put the little boxes over the output from the camera, and it's able to correctly size that image and make sure everything's there. The endpoint is, this endpoint is for CodeProject.AI. Probably don't have to change that. The mail interval is basically how many seconds will pass between each iteration, checking for new motion detection, as basically a queue of images that gets queued up, and every 60 seconds it checks that queue. If there's images in that queue, it will then email those to you. If there's not, it doesn't send you an email. So it's just basically the interval that operates on. So every 1 minute is probably too much for some applications, probably not enough for others. You just have to figure out what works for you. I would go with 60 seconds on mine, and it's probably okay. Now, the rest of these settings are basically related to email. So the mail from and the mail to are basically your email address that you want to send it to, and the mail address you want to send it from. And these are, of course, the SMT P settings for your mail server. So if you're using Gmail, smtp.gmail.com, the port, then your authentication and your password. Now, depending on what email service you use, you have to figure out what these are. But for Gmail, it's pretty straightforward. And the password is not the password you'd use to log on to Gmail with, but there is a way to get an application password for it. But if you're using another email service, you can definitely use that as well. But you don't want to overwhelm this with a lot of email because they do limit the number of emails you can send per hour. So just make sure that this variable up here, this mail interval, is not too high where it's sending one every second or something like that. Once a minute, maybe once every 5 minutes, it would definitely be within that threshold of how many emails you can send per hour per day, depending on who your email provider is. So once you have that all configured, you can save it and then you'll write it out. And then you're ready to go, and we will start all of this up. Now that everything is up and running, we can start everything up. So let's go ahead and start motion first. So I'm just going to type in motion and put it in the background with an ampersand. It'll still log the output to the console here. Then I can run Node.Detect.js and put an ampersand on that, and I'll put that in the background as well. Or we can just run it in the foreground for now, and this will log everything to the console. So we should start to see a stream of logs here. So it's detecting things that motion is writing. So it's finding files on the disk now, and we should get some output from the CodeProject.AI server. And there is the output from that, and it's basically queuing that up. And then it's sending a message now. So we should see something in the outbox here shortly. And now it's just processing stuff as it comes in. So it's just streaming now. So let's go ahead and see if I have anything in my inbox. Okay, so here's the output. Here's the email that it was sending. You can see that it detected my chair, and then me, of course. I'm sitting there recording things on here, and then there's a chair right kind of here in the corner too that it detected. So it did detect me at 68%, the chair at 86%. So it is able to detect things that are in the image. And so that would be useful for different kinds of applications. Now, it does have a lot of different objects other than chairs and persons. Of course, it did find a cup in this particular one right here. But you can also find things like bicycles, vehicles, trucks, different kinds of vehicles, and dogs and animals and that kind of thing. So it has I think 80 different objects that the models for YOLO are able to detect. So this is a particularly useful one for doing all things AI. So this particular one is great for what I'm doing here. Now you could take this and put it into some kind of environment and use it for a standalone motion detection. Now there's one last thing to do, and that is to set all this up to start when the Raspberry Pi boots. So I'm going to show you how to do that using RC local. So to make this start at boot, there's a couple of commands that we'll need to run. So we need to make sure that the container will start at boot. We just use a Docker command for that. So we basically want to tell the container to start at boot by running docker update, and you're just going to change the startup policy to restart unless stopped. And then this is going to point it to all current running containers, which is these containers right here, which is just one. So that updated my CodeProject.AI server to start at boot. Now, to make the other two pieces start at boot, we need to put those into the RC local file. Now, I need to get the paths for the executables though. So I'm going to use a command called which, and I can do which node and then make note of this. So it's putting the node executable in this folder right here. And so I'm going to paste that into something off screen so I can make a note of that. And I'm going to do which, and then I'm going to put into that motion. And that's going to tell me where motion's installed. So I need that because the paths might not be detectable when the machine's booting with RC local. So we need to put the full path to the executable when we configure this. So let's do the edit now. Let's do nano/etc/rc.local, and let's go ahead and edit this guy. You can see that there's an entry in there for media MTX where I ran this last time. So let's put the full path for motion in there at first, and paste that in there, and then put the ampersand, and then do the same for node. I'm just pasting in those values that I got from the command line using which, and now I need to put the path to the script images/detect.json or JS right there, and then put ampersand at the end of that, Control O, and then exit. And that's how you configure the various pieces of this to start at boot. So if I reboot the project, I will have it come back up whenever the machine reboots. So there it is, and everything is installed and running on this particular device. So this setup is a little bit more involved than the other ones that we've looked at, because we had to set up a lot more than what a simple camera would do if it was just capturing a stream and then sending that to an NVR DVR. We had to basically replicate a lot of the kind of behavior that you get from an NVR DVR, and that is to do the motion detection, to do the object detection, and then also send notifications. So we had to install all of the software to do all of that onto the Raspberry Pi. But once it's on the Raspberry Pi, it's a standalone setup, so you can install this anywhere, and you don't need any external dependencies other than power and networking, of course. So this particular one would work over Wi-Fi, over Ethernet, and you could power it using the AC adapter or power over Ethernet, however you're going to power your Raspberry Pi, and it would work just fine for any of those kinds of setups. So this is a great solution for a one-off type setup, but if you wanted to do something that was going to be more than 1 or 2 cameras, I would recommend using an NVR DVR for that rather than having a bunch of different cameras for it. But still, this has definitely got its use cases. The code is available on GitHub if you want to modify my code. I always accept pull requests, and let me know how you're using it. Drop a comment in the comment section down below. Of course, like and subscribe and share this with your friends. And as always, thanks for watching.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @theonemule. And as always, thanks for watching.